Welcome to this introductory video on the application and editing of sleep staging with Sleep Profiler. In this first segment of the video, we will review the methods used to auto-stage sleep. From the frontal sensors, the differential recording from AF7 and AF8 is the primary signal used to stage sleep. The power spectral characteristics of the conventional EEG bands plus the power from 32 to 128 Hz, which we refer to as EMG, is combined with the detection of spindles, cortical arousals, microarousals, and ocular activity measured from the left and right EOG channels to stage sleep. Each stage has a designated color. The signals presented in the upper portion of the screen provide behavioral measures of sleep continuity. The signals used to stage sleep are presented in the lower half of the screen. The upper hypnogram identifies the stages associated with the current screen presentation, and the lower hypnogram presents the entire night, with blue markings to identify the location of the current screen with respect to the entire record. Sleep staging is based primarily on the interrelationship between the power spectral density characteristics. As snoring begins at sleep onset, a decrease in both beta and EMG power provides the most apparent change. Increases in delta and theta power increase only after the transition to slow-wave sleep. Transitions between non-REM and REM are commonly distinguished by a marked decrease in sigma and alpha power and increase in beta power. In the top example, the EMG also decreases during REM. In the lower example, the power spectra is less intense. However, there is a marked change in beta power relative to the other frequency bands in the transitions between non-REM and REM. Cortical arousals are used to define epochs to be staged in one. Cortical arousals require a minimum 3-second increase in alpha power compared to the median alpha across the previous 120 seconds. This cortical arousal is confirmed by autonomic activation, identified by a 6 beat per minute increase compared to the pulse rate from the previous or subsequent 10th second. Microarousals are also used to stage N1. Microarousals require a minimum 3-second increase in either alpha or EMG activity. In this example, the EMG is elevated primarily in the middle portion of the arousal. Sleep spindles are included in the staging of N2. Spindles require a spike in both the absolute and relative alpha and sigma power. Simultaneous suppression of beta and EMG power is used to avoid false detection of benzodiazepine-related pseudospindles. The amplitude of slow-wave sleep is attenuated at the frontal polar sites. The 30 microvolt dashed lines assist in the confirmation of delta activity similar to the conventionally measured 75 microvolts. Sharp ocular activity in combination with high beta and low EMG is required for the detection of phasic REM. To assist with interpretation, the EEG signal is presented after decontamination of ocular activity. The contiguous sequence or block of REM epochs requires at least one epoch of phasic REM to accompany any number of epochs with tonic REM. Secondary stripes identify epochs that should be the focus of visual inspection because the auto-staging suggests an alternative stage may be appropriate. The auto-staging rules always assign the first epoch after awake to stage N1 unless there is a sleep spindle. Epochs with gross EMG activity will be staged awake despite the potential for over half of the epoch having undisturbed sleep. Note the timing and magnitude of the EMG activity can be visually recognized in a 10-minute presentation of the power spectra to assist in identifying those epochs that should be more carefully inspected. The epoch in which a cortical arousal begins is assigned stage N1. This epoch is staged N2 because the cortical arousal began in the previous epoch. Epochs with any number of spindles and only one arousal will be staged N2. Epics with 2 arousals and any number of spindles will be staged in 1. Cortical arousals detected during slow wave sleep are included in the arousal index but do not result in the epic being staged in 1. Epics are assigned light N2 or L2 when K-complexes or consistently elevated alpha or EMG power is detected. The proportion of total N2 sleep classified with the light N2 characteristic is included in the tabular report. Epics with beta bursts or beta spindles in proximity to phasic REM are classified as tonic REM. The proportion of total REM with phasic activity is included in the tabular report. Signal segments contaminated with artifact are colored red, and when the EEG signal is excessively contaminated, the left or right EOG signal may be used for staging. When artifact is extensive in all 3 channels, the epic is staged invalid. The percentage of good signal quality for each channel is provided at the bottom of the graphical report. Next, we will demonstrate the most efficient means to apply these rules to technical editing of the auto-scored records. A number of features are provided to speed up the editing process. The page down key will change the presentation to a 10-minute screen. The page up key will return a 30-second epic that appears at the left edge of the 10-minute screen. Alternatively, double left-click at any point on the entire night hypnogram to open a 30-second screen. The left and right arrow on the keyboard, or the functions at the bottom of the screen, enable scrolling throughout the study. The signals are defaulted to a plus or minus 75 microvolts for the EOG and plus or minus 50 microvolts for the EEG signal with a 0.1 Hz high-pass filter applied. When more than 3 seconds in a 30-second epic staged N2 or N3 exceeds the presentation range, the sweat or breathing artifact is removed with a bandstop filter applied to all 3 channels. This filter can be manually applied using the down arrow or removed using the up arrow. Alternatively, the filter and unfilter buttons at the bottom of the screen can be used. Impedance values presented at the top of the screen can assist in interpretation of signals contaminated with artifact and identify when the sensors are not properly affixed. The clock time and elapsed time based on the left edge of the screen and the elapsed time associated with the location of the mouse are presented at the bottom of the screen to assist with navigation. When the left click and drag feature is used, the elapsed time or distance of the region is presented at the bottom of the screen. The sleep stage can be edited by multiple means, and in all cases a T will be placed in front of the stage label and a red box will identify when the stage was edited. The stage can be edited using the designated keypad entry when on a 30-second screen. Once changed, the presentation will automatically advance to the next 30-second epic. Multiple epics can be edited using the left click and drag feature. Alternatively, right-click on any stage stripe to edit the stage. We are now going to edit 2 studies, applying the techniques where the auto-staging is confirmed by review of the power spectral density characteristics on a 10-minute screen with selective review of 30-second epics. Our goal is to present this information fairly rapidly and to provide you the opportunity to review these same records at your convenience at www.sleepprofiler.com. Just click on the Guest Exploration icon. You will need to install the latest version of Java to review the signals, and any edits that you attempt to make will not be saved. The first study we're going to edit is named Sleep State Misperception. I'm going to left-click on the Actions and Reports, and you'll see there are options for entering or editing a sleep profiler questionnaire or sleep diary, or editing patient information. Interpreting physicians may wish to review the sleep profiler questionnaire. The bottom of the second page lists medications that the patient is taking that may have an impact on the EEG. Next, we are going to review the Sleep Profiler report. Always select the top report as that is the most recent one generated. The clinical history at the top of the narrative report captures information including the Insomnia Severity Index, Epworth Sleepiness Score, measures of depression using the PHQ-9 questionnaire, and measures of anxiety using the GAD-7 questionnaire. The tabular report focuses primarily on sleep architecture, sleep latencies, and sleep continuity information. We've included the normative ranges from home polysomnography and underlying values so that if the patient is below the low value or above the high value that is underlying, then that indicates a level of abnormality. When the sleep diary is completed by the patient and entered, this comparison report will show the differences between what the patient thought happened and what actually occurred. In this example, the patient thought that it took them 120 minutes or 2 hours to fall asleep, when in fact they fell asleep in 38 minutes. Clinicians find this report useful when they're having a consultation with the patient. We're now going to open the study for editing. The study opens on a 30-second screen, and the first epoch is always staged awake. This is the overnight hypnogram showing the first, the second, and the third sleep cycle. By hitting page down, I will transition to a 10-minute screen. As we begin to transition through the record, we see a lot of movement, and the black EMG line in the power spectral density is quite high, indicating that the patient is still awake. Here the auto-scoring identifies that the patient has transitioned to sleep, and we see an increase in the green sigma activity, suggesting the patient is beginning to transition to non-REM sleep. I'm going to open this epoch by left double-clicking and confirm sleep onset. I'm going to use the left arrow going back in the file toward the beginning of the night. I see some EMG activity and beta activity suggesting the patient is likely awake here, and again here, and again here. So I'm going to left drag and click and select wake, and the staging of these epochs have now been changed. So now I'm going to begin transitioning through the record. Using the right arrow key, I'm going to move forward into the record, and I see an intermittent pattern of N1 and wake and N1 and wake. And it's questionable whether these periods of N1 are correctly called. So I'm going to left double click on this epoch, and I'm going to go back through the record using the left arrow key. And from this point, I'm going to stage these epochs as awake. And I'm going to left double click and confirm. So I'm going to press page down, and with the left arrow key, go back and convert to wake. Then use the right arrow key, and now we can see that the patient is transitioning to non-REM sleep with the dark blue stripes indicating spindles and the green power spectral activity from the sigma power. So I'm going to continue through the record. And now they're in slow wave sleep, and I'm going to check by left double clicking and confirm that the amplitude is within the plus or minus 30 microvolt range in a sufficient portion of the epoch to confirm that it was properly staged. It is, so I'm going to press page down, and rather than check all of these epochs, I'm going to assume that the auto staging will be scoring them all consistently. Here is the first transition from non-REM sleep to REM sleep. Note that the difference of sigma power, that green activity, gets much lower during REM sleep, and the beta activity increases. You should always confirm transitions between REM and non-REM by simply left double clicking on a REM epoch and confirm that the sharp ocular changes associated with phasic REM are in at least one epoch within the REM block. Now I'm going to hit page down. Here the patient awakens. You can see the movement, and they begin to transition back to non-REM sleep. They've transitioned again to N3 sleep, and here is the delta activity confirming the appropriate stage. Press page down and the right arrow. Here the patient awakens and begins to transition back to sleep. I expect that these two epochs should be staged awake because of the large EMG activity that occurs in both. So I will left click, and you can see the mitral arousal here, and there is some snoring. Given the snoring pattern, I'm going to leave these two epochs as they are. So press the right arrow key, and again transitioning through the record, and we begin another transition from non-REM to REM. There is the phasic ocular activity. Press page down and continue. Again, the transition to non-REM sleep. After the patient awakens, you can see a distinctive pattern as they begin to transition to sleep, where there's increased EMG activity associated with breathing instability. So I'm going to left click, and you can see the arousals here and the arousal here, and I'm going to leave those stages as they are. We have now finished editing the first 4 hours of the record. Pressing the right arrow key, I'm continuing to review the signals quite quickly because the power spectral characteristics are suggesting that there is no need to inspect 30-second epochs. After the awakening, I see the sigma activity suggesting correct assignment of non-REM sleep. And now the patient is transitioning again to REM. So I'm going to left click, and there is the phasic ocular activity. Press page down, and because of this awakening, I'm going to check again this REM block. There's the phasic activity, so I can press page down. As the patient transitions back to non-REM sleep with the blue stripes identifying spindles, and now the patient awakens, goes upright, and we will need to identify sleep onset again. Pressing the right arrow key, we'll go forward through the record. At this point, the auto staging is indicating that the patient has fallen asleep. To be conservative, I'm going to convert this epoch to wake, and I'll inspect the epoch. You can see the small spindle-like activity confirming that the staging is correct. Here's another example of an isolated epoch amongst wake. So I'll go in and check, go to the left one epoch, and I'm going to leave this as it is. These three REM epochs look a little out of place, so I'll go in and confirm, and you can see the dense ocular activity, the phasic activity. So I'll press page down. This N1 stage looks a little out of place. I'll check it. To be conservative, I'm going to edit this to wake by pressing 0, and the software automatically advances me to the next epoch. Using the left arrow key and going back, I can see that this epoch is now identified T awake, meaning the technician has staged this to wake. Pressing page down and the right arrow key, and we're approaching the end of the record. This blue box identifies the location within the record that's being presented on the screen. Pressing the right arrow, I now reach the end of the study. So I'm going to press save, confirm that the edits were successfully saved. And if you've acquired a 2-night study, now you can go in and edit the second night. In this case, I'm going to close the screen, and now I'm going to review a study for the subject labeled Undetected OSA. Press page down, and we can see that the patient fell asleep within 5 minutes. So we'll go in and confirm sleep onset. We can see the slow rollers and alpha activity. Pressing page down, in the next 10-minute period, we see an increase in sigma, the green activity, dark blue stripes, that is spindle activity, as the patient transitions into deeper non-REM sleep. Here we see a large crescendo snore, autonomic activation, and we can see a cortical arousal occurring here. I see that pattern occurring again here, leading to a large arousal. Patient falls back asleep, and now they transition from slow wave sleep and awaken with the same pattern. I see a single REM event, and I'm going to press 1. When I press page down, I can see that there's a T in front of it to indicate that it was technically edited, and now it appears that the patient is transitioning to REM. So I'm going to left click, and there's the phasic activity. I'm going to leave the staging like it is. These arousals make sense to call them N1. This is a micro arousal where it combines both EMG and increased alpha activity. Press page down and continue reviewing the record. Here the patient is transitioning from non-REM to REM. With the secondary stripes, it may require editing. So I'll left click, and there's the phasic activity. Now you can see the difference in the pattern from REM and non-REM. This N3 epoch looks a little out of place given the awakening here. So I'm going to left click, and I can see the activity that does meet the requirements, so I will leave it. In this transition from non-REM to REM, we see an epoch that's marked REM with the secondary slow wave sleep, or N3 stripe. It seems counterintuitive, but large amplitude phasic activity after decontamination can leave patterns that exceed the plus or minus 30 microvolt range and can get misconstrued as slow wave sleep. Pressing page down, here are a couple of more patterns that will likely be high phasic activity. When the phasic activity is plus or minus 100 microvolts with sharp edges, it gets detected as artifact and is marked red. The balance is used for staging the epoch. The first epoch after awake is always staged N1 unless there's a spindle, and we see an arousal and a high peak in alpha activity, so this epoch is properly staged. These two REM epochs look a little out of place, so I will left click, and with the movement and the slow rollers, press 1, go forward 2 epochs, we have movement again and the transition back to sleep. I'll press 1, and we see the transition here to REM sleep with the phasic activity going back, and I'm going to leave these epochs as they are, and we're now at the end of the record. From a signal quality standpoint, this was a very good record, and this is confirmed by the impedance values presented at the top of the screen. For the entire night, the impedances were less than 5 kiloohms. If you are a technician conducting the review, press Save, and as an option, you can go in and convert the status to interpretation required. This will automatically send an email to the clinician to let them know the study is ready for them to review. For clinicians, there's the option to automatically insert messages into the bottom portion of the narrative report. The exact wording of these messages is provided in the technical manual. Alternatively, I could press Clinician Comments and type in a message or copy a standard message from a Word file to insert into this section that will appear above the signature on the report. The last step for clinicians is to save the final report. The message will remind you that only one report can be generated as a final report for each study. I'm going to select Yes, and it provides me the opportunity to insert a signature that will appear on the narrative report. So I'll press OK. The final report is saved, and when I press refresh, I will see that it says that the final report is now available. This concludes the training video on the application and editing of sleep staging with Sleep Profiler. We recommend that you review these techniques using the same records available on Guest Exploration at www.sleepprofiler.com.